Hi, good morning. Welcome to today's my topic about electrostatics. Yes, we know that electrostatics is the study of stationary electric charges. It arises from the forces that electric charges exert on each other and are described by Coulomb's law. Charge is a property of an object by virtue of which it applies electrostatic force of interaction on other object. So charge is a property of an object by virtue of electrostatic force. By virtue of electrostatic force. Charge is two types. Charge is positive charge and negative charge. We know that unlike charges attract, see here, positive charge and negative charge both are going to be attracting to each other. See the arrow marks of the two bodies of charge Q0 and Q1, plus Q0 minus Q1. They are going to be attracting. See, in other figure, like charges repel. See Q0 plus Q1, positive charge and positive charge, plus Q0 plus Q1, both are the like charges. That's the reason they are repelling. So like charges will be attract, like charges will be repel. So that is the property of the charge positive and negative. Let's see. A piece of plastic rubbed with fur. When plastic is rubbed with fur or glass is rubbed with silk, it attracts small pieces. So plastic and fur is nothing but the air of sheep, animal sheep, or glass and silk cloth when they are attract. See when they are rubbed, so the bodies will attract small pieces of paper. It is said to be electrically charged. It's said to be electrically charged. So here charge is two types, positive and negative. Let's see from the above interaction what is negative, what is positive. The charge on plastic. When plastic is rubbed with fur, plastic is rubbed with fur is negative charge. Plastic and fur interaction is negative. Glass and silk is positive. When glass is rubbed with silk, it is on positive charge. This phenomena first observed by Thales, Thales of Miletus in 1600 BC. Thales of Miletus in 1600 BC. How? He observed when a rubber amber is nothing but a gemstone material which can be used in a metal for the shining. When amber used or rubbed with fur, he found that amber attracts tiny particle of sawdust. Examples of electrostatics. There are many examples are there. Here are the few. The attraction of the plastic wrap to your hand after you remove it from the package. So when you purchase item from Amazon, Flipkart or Swiggy somewhere, so there are the packages will contain plastic wrappers. When you remove the plastic wrappers, when you throw away the plastic wrappers try to attract your hand even though you want to throw out, but they are try to align your body. So that is electrostatics. The attraction of paper to a charger scale. So when you combing your hair, after combing your hair, the comb will attract tiny particles of paper. That is attraction of paper to a charged body. Damage of electronic components during manufacturing. During the manufacture of electronic devices, some of the parts or components will be damaged. So the damaged components will also shows electrostatic phenomena. Electrostatic force. Electrostatic forces are attractive or repulsive. So the attractive or repulsive forces between particles that are caused by the electric charges. Because of electric charges, particles are generated. Because of the particles, between the particles, a force is generating. It may be attractive or repulsive. That force is called as electrostatic force. This force is also called the Coulomb force or Coulomb interaction force. Why? Because it is absorbed or invented or discovered by Coulombs in 1785. F equal to. So what is that? The Coulomb statement states that F is equal to K into Q naught Q1 by R square into R caps. That means the force of attraction between two bodies is proportional to the product of two charges of Q naught Q1, and the force of attraction is inversely proportional to the square of the distance between two bodies. Here K is the proportionality constant to R caps is a unit vector where it is equal to 1, where F is the electric force, K is the constant of proportionality, Q naught Q1 be the amount of charges on each body, R is the distance between the two charged bodies, and R caps is the unit vector which means 1. Here Coulomb formula states that the force is proportional to product of two charges. F is directly proportional to Q naught Q1 and inversely proportional to the square of the distance. That is, F is inversely proportional to 1 by R square. So here K means K equal to 1 by 4 pi epsilon naught, which means 9 into 10 to the power of 9, and the unit is Newton meter square by Coulomb square. Here, epsilon naught is nothing but relativity permittivity in free space. Relativity permittivity in free space. Sorry, not relativity, just permittivity of free space. Permittivity of free space. The value of permittivity of free space is 8.85 into 10 to the power of minus 12 Coulomb square by Newton meter square. See, K equal to 1 by 4 pi epsilon naught. If everything is 4 pi is constant, then K is proportional to, sorry, K is inversely proportional to 1 by epsilon naught. See here, K equal to 1 by 4 pi epsilon naught. 4 pi is the constant, then K is inversely proportional to 1 by epsilon naught. See here, K value is how much? K, the dimensions K is Newton meter square by Coulomb square. So here the permittivity dimensions are Coulomb square by Newton meter square. That's it. Let's see electric field. An electric field is a field or space around electrical charged object where any other electrical charged object will experience a force. Due to the positive and negative charges, a force is generated. Because of force, a area is affected. A area which is affected by these forces, that area is called electric field. The main reason is because of charges. Electric field lines. Electric field lines can be used in pictorial form to describe the overall intensity of the field. So, electric field intensity can be designed or explained properly by a pictorial form or curve form, design form, that is called as the electric field lines. This pictorial representation or form is called electrical field lines. Electrical field lines can be defined as a curve which shows direction of electric field. It shows direction of electric field. When we draw tangent at its point, the concept of electric field was, this was proposed by who? This statement is proposed by Michael Faraday in 19th century. Michael Faraday. The strength of electric field is directly proportional to the length of electric field lines. So electric field strength is proportional to electric field lines. Electric field is inversely proportional to square of the distance. Electric field is inversely proportional to square of the distance. Electric field strength decreases. So electric field strength, what is happening? Decreases as we move away from the charge. As we move away from the charge, the direction of arrows or field lines depicts, that means corona direction, that means decreasing. The direction of arrows or field lines depicts direction of electric field, which is pointing outwards in case of positive charge and pointing inwards in case of negative charge. See, positive charge, negative charge. Out positive, inward negative. Lines of force. So lines of force. An electric field is measured by a term known as electric field intensity. If we place a positive unit charge near positively charged object, the positive unit charge will be experience a repulsive. So here when two bodies of positives are kept closer to each other, then there is a phenomena exist, that is an repulsive property is existing. There is a repulsive nature is existing. That because of repulsive nature, a force is existing that is called repulsive force. So that's the reason the positive unit charge will move away from the charged object. The positive charge will move away from the positive object through a imagined line. The imagined line is called line of force. The imagined line is called line of force. See, positive charged body. This is on positive unit charge. So both are positive. Now positive unit charge is bringing or moving towards a positive charged object. Then what is happening? So this positive unit charge will be repelled. So how it is repelled? By producing a repulsive force. This repulsive force moving through a imagined line. That imagined line is nothing but line of force. Similarly, attractive also existing. Then properties of electrical lines of force. They start from positive charge and end in negative charge. The tangent to it any point gives the direction of electric field at the point. They never intersect each other. Lines. They tend to contract longitudinally, expand laterally. Contract longitudinally, expand laterally. They always enter or emerge normal to the surface of a charged conductor. They always enter or emerge normal to the surface of a charged conductor. They are close together in regions of strong electric field and far apart in regions of weak electric field. The field lines are always normal in the direction of electric field. Magnitude of electric field is represented by density of electric field lines. Electric field lines are imaginary in nature. They are simply used to represent pictorial form of electric field lines. If we draw tangent any point of electric field line, we get direction of electric field. The electric field lines are closer where electric field is strong and farther where the strength of electric field is weak. Electric field lines can pass through an insulator. The number of electric field lines per unit cross-sectional area is directly proportional to electric field strength of that area. Electric field lines contract longitudinally. Thank you.